Here we're looking at example 4 from our 1.5 set of notes. We're asked, given this following function, find the limit as x approaches -2. So then we end up with the limit as x approaches -2 of x squared minus 4 over x cubed plus 2x squared plus x plus 2. Now we can go ahead and first start out by factoring this item. So then we end up with the limit as x approaches -2 of x plus 2 on top times x minus 2. And on the bottom, it has probably been some time, but believe it or not, we can actually break this item up and do factor by grouping. So we're going to go ahead and split it up right down the middle. And again, part of factor by grouping is actually recognizing maybe potential factors that you're looking for. So I'm just going to go ahead and try and factor out this by breaking it up down the middle. It's not always going to be the middle. You might have to break it up here and factor this piece, or you might have to break it up here and factor the first three terms. It just really kind of depends on what you're trying to factor. But if I go ahead and break it down the middle, then I have an x cubed plus 2x squared plus x plus 2. So all I did was pretty much throw parentheses around those items. Now, just looking at this bottom, again, the top's already factored, so we don't have to worry about him. But just looking at the bottom, it looks like they both share in this first part a common x squared. So let's go ahead and pull out an x squared. So if we pull out an x squared out of both of those items, we end up with what times x squared gets us x cubed? X would accomplish that. Likewise, what times x squared would give us this 2x squared? 2 would accomplish that. This second piece, we didn't have to factor out at all. So now this is where factor by grouping actually takes apart. Like, we actually grouped it right here. We grouped this first piece together. We also grouped this second piece together. And now, notice that they share a common x plus 2. Now, a number right in front of this second set of parentheses would actually be 1. It's not written there. It's assumed it's 1. And you could even distribute, and you'd see that you'd end up with the same thing. And that's really going to help us out as we continue to factor. So we have the limit as x approaches, oops, this should be -2, of x plus 2 times x minus 2. And what we're going to do on the bottom is literally remove this x plus 2 from both items, again, because it's a common factor from both items. So then we end up with x plus 2 times, well, what times x plus 2 gives us x squared times x plus 2? Well, this x squared would accomplish that. Likewise, what times this x plus 2 would get us this 1 times x plus 2? Well, the 1 would do that. So that 1 really acts as a placeholder for that x plus 2. Now, we can go ahead and cancel something. So these x plus 2's end up dropping out, and that again was really the issue that it was giving us with that 0 over 0 indeterminate form if you tried throwing that in originally. So now we can go ahead and use our direct evaluation. Looks like we end up with -4 over 5. So because this canceled, because we saw that cancel, we should see a hole there. And now let's go ahead and just verify that the left side does in fact meet with the right side. So if we did the limit as x approaches -2 from the left of our function, again, this would be our simplified part. We would end up with the limit, I'll just write it out so it's a little bit more thorough. negative 2 from the left of x minus 2 over x squared plus 1. It should, if you use direct evaluation, just come out to be negative 4/5. Likewise, when we take the limit as x approaches negative 2 from the right side of our function, in other words, that simplified version, again, just using that direct evaluation, you get the exact same thing, negative 4/5. And as a result, the one-sided limits end up matching, and so we should see a point, a hole, at negative 2 comma negative 4/5. And this actually makes sense both from the left side and the right side. So again, though, really the purpose of this example is to kind of refresh some of your algebraic skills, because you could have to maybe factor by grouping, and you know that's pretty important when we're talking about limits. So it's really good to refresh those skills, and notice that it did cancel. So we didn't even really have to look at the since it created that hole, it didn't really create we couldn't really use that scenario where we plug things in that's close to him and then look at the signs and see if it's going to positive or negative infinity, because again, it's approaching an actual hole, some point. So we couldn't, unfortunately, use that strategy. But again, though, that is example 4 from our 1.5 notes.